So last class we defined the real definition of trig, right? So remember, it was based on the coordinates. When you have a terminal arm, okay, so when you have a terminal arm, let's call that point AB. If that's theta, the sine of theta is B. The radius is always the result of doing a squared plus b squared, right, from the circle equation. So sine of theta was not opposite over hypotenuse. It was the y coordinate divided by the radius, right? And the adjacent, instead of being adjacent, it's the x coordinate divided by the radius. And tangent of theta was equal to b over a, right? The y coordinate divided by the x coordinate. Now something really nice happens. Instead of this circle being any radius we want it to be, if the radius is just set to be 1. Suppose this radius is set to be 1. What happens to this sine theta, cosine theta, and tangent theta?
B over A.
Right, B, A, and this stays the same, right? Okay, so what does that mean visually? If this circle was unit circle, so we call that a unit circle, now we can visualize sine as the arm rotates. Okay, sine is simply the height of this arm rotation. So what is the sine of this angle? It's that height. Okay. So let's say I have on a different angle rotation, right? What is the sine of this arm rotation?
Same as the first one.
This is different. It's different height. It's that length right there. That's the sine. Right? So sine of, this is not B, it's a different rotation. Let's call it like C and D, okay? So that's D right there. So sine of phi is D. So what's happening? As the arm rotates, right? As the arm rotates from 0 degrees to 180, what's the sine of sine? That sounded weird. What's the sine of sine? Do you notice how the sine is positive? Because we're talking about the height.
Yeah.
What happens if we go over 180?
Becomes negative.
Yeah, becomes negative, right? So this is the first analysis, and we're going to summarize all of this. So sine is positive here, here, but negative down here, because we're talking purely in terms of height. That's what sine is, just height of the rotation. So let's say we do an example here. Sine of 120 degrees, right? So what we do here is this. We like to refer this back to the relative acute angle. So which angle rotation will have the same height as 120 degrees? Okay. So 60, right? If you think about it, it's going to be 60. So look. Okay, so here's 120 degrees. Okay. 120. That makes this 60. So which first angle rotation will have the same height as this one? Clearly, right, this complementary, the supplementary angle, 60. They'll have the same height. So for that reason, we can say this is same as 60, because they have the same height. Now, notice what I said about how do we find 60? The clear relationship is supplementary. The angles are supplementary. So actually we should write this first. When we write this, sine of 120 is equivalent to the supplementary, which is 180 minus 120. So it's going to equal to 60. Okay. Oops, sorry. I meant that, right? 120 is equivalent to 180 minus 60. So sine is equal to 60. So we can generally say, so I mean from here we can say this is equal to root 3 over 2. What is the actual height? It's root 3 over 2. So in general we can say this actually. Sine of 180 minus theta will always equal to sine of theta. So the sine, the height of 180 minus theta will equal to just sine of theta's height. So what I showed you here is assuming that this is an acute angle, right? If this is acute, this is in quadrant 2, right? But what if this was not acute? What if this was a lot bigger than acute? Does it still work? And we'll show that it does work, but not right now. Okay, this is actually going to be true for no matter what the angle theta is. But before we go into that detail, let's do another example. Okay, so sine of 210, if you were to draw that, right? So from the rotation, it's all the way here, right? Okay, so there's 30 right there. Now, this rotation has clearly a negative height. Now, if I extend this, right? If I extend it over here, like this, right? Do you see that this height right here, okay? That height right there is the same height as this one, except they're opposite in sign. Okay, so this would have to equal to sine of 30 degrees, but just negative in value. Right? Same height, but they're in opposite in sign. Right? So let me derive a formula for this too. So this, the relationship here is this. That sine of this compared to 180 degrees, it's actually plus 30, right? This plus 30 from 180 makes it go into the third quadrant, right? So because it's in the third quadrant is below the x-axis, right? The third and the fourth, they're below the x-axis. I know it's going to equal to sine of 30, but it has to be negative. Okay, that's the reasoning. So it's minus half. So this is how you show the steps, okay, like this on a test.